There we go. So welcome everyone to today's webinar on integrating CAD and GIS with a special focus on our old favorite MicroStation, and in particular DGN or design files. So we're going with kind of a Lego theme today because we got a lot of blocks to fit together to put this together. So just roughly in terms of an agenda, we're going to be looking today going both ways, both CAD to GIS and, not to be forgotten, GIS back to CAD. And so Mark is busy tuning up in Manitoba to show us some of the GIS to CAD, and Lena here with me in beautiful Surrey, British Columbia is going to be looking at doing CAD to GIS. So just in terms of who we are, I'm Dale Lutz. I'm one of the co-founders of SAFE. Been here for more than 20 years now, so I'm getting a little bit old. I was just a young lad, really, when the company started, and I'm joined by Lena, who comes to us. You've been at SAFE how many years?
Almost 6.
And before,
actually 6 already.
6.
It's September.
Wow. And I know you were a MapInfo person in your previous life.
MicroStation and MapInfo, both.
Right. So we've got a long time. We've got basically 3 lifers with MicroStation today, and we introduced Mark.
We all worked at the same company in Richmond at one point, I'm guessing.
All of us are ex-MBA.
Yes.
We are. Wow, that's just freaky. This is like an episode of Lost. We have all these things in common. So we've got also a panel of experts standing by. Candace is there. Mark Stokes, who brought us our muffins. Thank you, Mark. Dave Campanis, who's more of an AutoCAD guy, but he also knows his way around MicroStation. He's really a CAD of all trades. And Regan, the lead CAD developer, who looks like he's pressing up against his glass wall there, he's standing by, and I was going to make a joke about if you can stump Regan, we'll do something for you with a good CAD question, but I'll limit the prize to see who will really stump Regan. So anyway, Regan theoretically is standing by as well to help us. So at any time, don't be afraid to ask questions, and we're going to be stopping to kind of review them a couple times during the presentation. So, just out of curiosity, who's new to FME? And if you raise your hand, which is that little button there, this is the first time I've ever tried this poll, so let's see what happens when people start raising their hands. Are they oh, there's some. Elena's sorting by the hand raising. So is anybody? Oh, there's a few that are brand new. So thanks very much for joining us. FME is a product that's used to move data between a wide variety of formats and systems, and today we're focusing really on its roots, which was CAD to GIS, and in particular DGN to GIS. Wow, there's quite a bunch of you that are new, so thanks so much for tuning in and letting us know. These links on the bottom, and we'll be mailing these out to you, are great places to go to get some more introductory material on what FME actually is. And you can sign up for a kind of a basic intro webinar. Actually, our statisticians have informed me that about 30% of you are new users, so that is really, really humbling. Thanks so much for tuning in. Kicking off our fall webinar series as well. So we do these about a couple times a month. So I thought we would jump right in without much more introduction and just get started on a classic old problem. Let's do some CAD to GIS. And we want to extract GIS attributes from CAD properties. And this is a very common, this is really where we started at SAFE, and what was the core of how our product really began its life, was helping people fish out the actual data that's inside of a CAD file and encoded in there in those bits and bytes of PDP-11 goodness, and bring them into something more useful for the GIS technician who isn't as enthusiastic about knowing that color 3 means that it's a paved road, or that the style of 1 means the road is loose gravel. So we're trying to get that information out and add value to it. And so here's what our map looks like. This is actually one of the first maps we ever worked with at SAFE. And again, the graphic group, if you're a MicroStation person, that was a nice bit of 16 bits there that you could tuck values into, in no sense letting that go to waste. And so people would do things like put, say, the number of lanes in there. In this example, that's what's the case. Or they might have also put things into the line style, like the road type in this case, where 1 meant it's a loose road, 2 means it's paved, 3 means it's rough. And so we can look at our data like this, and we can also see it on top of a background map like that. And so with that, I'm going to try my luck at flipping over here. And this is the FME Data Inspector. So I've started that up. And I'm just going to show how I would open this up I'd pick my design file, I'd go to where it was. Because MicroStation doesn't know a coordinate system, if I am interested in seeing it on a background map, I need to say the coordinate system. And so I'll do that, and I hit OK. And then this is, again, part of FME. The data inspector runs, and it reads that data in and renders it, and here it is on top of the background map. I can turn off the background map just to see what I've got, and then I can go out here and maybe select something, and now here I see all the properties, and my goodness, are there ever lots to choose from when it comes to MicroStation files. These are all the things that we fished out, and at the end I'll tell you some interesting stories about using the Z or Z value, but I won't get into that now. So anyway, here's all the properties associated, and I can click around on here and see that this one, the style was 2, which again I remember was something. Here's my specifications. So again, style has the road type, and graphic group the number of lanes. So the number of lanes of that one that I happened to pick was 4, and that must mean it's a 4-lane road there. And this is a file that I put together that is a CSV file that maps the style to the road type. And so now I'm going to go and say, great, I've looked at this data, I kind of know what's there, I believe it's the spec, it seems like it lines up with a background map that I configured in my tools options. This one's the MapQuest one, but we have other ones like ArcGIS Online is a good one if you're an ArcGIS customer to check if the data is right. And now I'm going to start up Workbench and say, let's translate this into file geodatabase, doing something useful along the way. And so again, I just drag out my roads DGN onto here. Again, because I want to go to the geodatabase, I will tell it the coordinate system. I'll say that's okay. Now I've got something that represents the data. This file had only one level in it, so I'm seeing just that one level. And I want to now begin the work of decoding this. And so what I'm going to do is use something called a joiner, and I'm going to go to this joiner and configure it, and that was a little bit of cooking show magic. Before that time, I had said that it should look at the lookuptable.csv, and in this parameters here, I can see that it's got field names on the first row, and here's the data. That looks good, and so that's all happy. I told it to join the style to the style that's inside of that lookup table, and we're going to fish out the road type, and we're doing one-to-one match, and that all looks happy. And so now if I open this up, I can see that I've got a road type. And that makes it time for me, if I'm worried about it, I can now do what's called an inspector. And I'll tell this inspector to group by the road type. Here we go, so that when I run this, I'll see different values for the road type. And we will go and run this. And this is a way that I can kind of see if my workflow is working correctly. And while it's thinking there, I'm just going to zoom this open. So we can see that we've got a bunch of loose roads, some paved roads, and some rough roads. And if I turn these all off, I can start to then see, okay, that's the loose roads, here's the paved roads, and here are the rough roads. Okay, and so that's looking healthy, so I'm happy with that. And so then I'm just down to saying, well, where are we going to output this to? So let's add a writer, and I think I'm going to go to File Geodatabase. Does that seem good to you, Lena?
Yeah.
All right.
Hey, Dale.
Yeah.
Can you click the Browse button next to the formats and show folks the list of formats if they're new to FME?
Right. There's a lot to choose from. You are limited by your imagination. And so, yeah, so here's, well, actually, if we just type in Esri, there's like a screen full of Esri formats by themselves. And I was picking the geodatabase file. If you're a GML person, look how many you got to pick from there. If you're an AutoCAD person, there's pretty much a screen full of those too. If you're a web person, you might be doing KML. You're a Google person, there's lots of Google choices. Who have I left out? MapInfo people?
Uh-huh.
Oh, my Intergraph friends. They have a whole bunch as well. Who else? I think that gives folks the idea. There is a lot to pick from, and I've gone for File Geodatabase. And I'm just going to put it in this output directory. Yeah, we'll overwrite that thing. And I'll make sure this is set to overwrite. Yep. And we will go like that. And I will add a new feature type, which is a new table. I'm going to call this roads. This is going to hold polylines. With going to Esri, you always have to say that. I'm going to want a couple of attributes. I'm going to go for the road kind, which I'll go make a text type of 30, and the num lanes, number of lanes. We will make that something a bit more interesting. It's a small int. I'm going to be really careful. I'm going to pretend I'm on a PDP-11 and save storage space and go for a small integer there. And then I just take this guy and drag, whoops, yeah, I don't need that anymore, so I'll get rid of that. And I connect this up. And now that thing was red telling me, hey, nothing's going in here, so I want to match the road type to the kind, and I want to match the graphic group to my number of lanes. With that in hand, I run this, and this should light up with a bunch of numbers in a moment as we do the work. Yep, all of our data went there. And now I'll just do one last thing. I won't fire up ArcGIS right now because I need to get Lena going, but I'll just do a quick inspect. This is now reading the file geodatabase, and there it is. And here, there we got our background map. And this time I actually have a worthwhile attribute table where I can sort it by the kind, for example. And it was, we should start seeing, yep, some different things, or the number of lanes, and so on. So that's really my snap demo, and now I've got myself a file geodatabase that's a whole lot nicer to use than that CAD file was if I was a GIS person. And I think with that, I'll ask our producer to hand the presentation right over to Lena, who will take it from there.
Okay.
There we go.
Let's show my screen. And so first of all, let's take a closer look at the differences between CAD and GIS data. The first thing that comes to mind is probably the data structure. In CAD, the features or objects are usually split into layers or levels, while GIS data structure is more complex. It might include additional rules, and we probably missed a poll question.
Uh-oh.
Should we get back to the poll question now?
What was the poll question? Sure, we can do the poll.
Yeah, let's
Sorry,
do the
Lena.
poll first, and we will get back to the slide.
Right. Here we go. Yeah, we wanted to also ask you, now that you've seen kind of what's possible, what are the things you might want to do when you're coming from CAD to GIS? And as Lena was saying, while we're taking the poll, we can actually talk about some of these things. The CAD is a visual-oriented thing. There's annotations as opposed to attributes generally. There are ways of tucking attributes in, but they're more tricky. On the GIS side, really, it's all full attributes. And the visualization side, for the most part, is much more limited.
Yeah, so for the CAD, additional information is coded as visual attributes quite often, as we were talking about line styles, for example.
Yes.
While it was in CAD. In GIS, it would be attributes or...
Sure, and in CAD, you'd have a little picture of a dog barking to represent a dog park, but in the GIS, maybe you'd have a point. And you wouldn't want the dog barking in the GIS.
No, definitely.
Right. And the coordinate systems, I know I remember actually a MapInfo user called me years ago and said, Dale, your CAD file reader is incorrect because it's not giving me the coordinate system. They've never, because they're from MapInfo, they never imagined you could have a GIS file without a coordinate system. And so I explained to them that there wasn't a coordinate system in these things, you have to know it, and the person was kind of sad and then said, this is going to be a big problem, and they were right. So
yeah, it is quite often.
So there we're showing the results. So actually, good thing, a lot of people interested in getting the attributes out of CAD, which is really what we're mostly focusing on.
Yes.
And fitting the CAD into GIS. There you can all see it. And then going back the other way, that's what Mark's going to be talking about. There's still a sizable chunk that want to do that as well. So that's great. And so with that, I think we can go back and let's see, Lena, you need to share your screen. There we go. You're in business.
Am I? Oh, yeah. Okay, good. So let's go straight to one of the demonstrations that we have. We will take a look at the data. These are parcels and blocks, and parcel numbers and block numbers. As a GIS person, what I would expect to have some polygons and some attributes as block and parcel numbers attached to them. As a matter of fact, what I've got from CAD data are boundaries. These segments are boundary parts of the parcel and block boundaries. So to transfer this CAD data into GIS, what would we need to do? First of all, we would need to create polygons. Then we would need to attach information about these numbers to the created polygons. And this is how we would do that. This is the workspace that would do the trick for us. Let's see what it does. First of all, we are reading our CAD data. It was a DGN format, and the data was split into levels. We had a separate level for parcel boundaries, another level for the block boundaries, one level for parcel numbers, and another level for the block numbers. So first of all, we would probably want to create our polygons. And this can be done with the transformer that is called Polygon Builder. The only problem was when we started to build these polygons, we realized that the boundaries are not topologically correct.
No.
No.
Is it really true that there's bad data?
No, there is no bad data. There is a data that we have to deal with, and we just need to.
It's not really bad. You have to just look at the good part of it.
Yes.
And get the good part out.
Yeah,
Okay.
definitely.
You're
And
very
we
positive person.
definitely can do that. We have another transformer that is called Snapper that would snap the ends of the lines for us. After the lines were snapped together, we can build the polygons.
Yes.
And then, yeah,
I'll just mention, if people need even higher end cleaning, there is an extra cost thing you can buy for FME called the MRF cleaner that uses technology from a company that's been around for a long time to do very complex cleaning. This is just simple snapping,
Yeah.
but that's actually adequate for many situations.
Yeah, in many cases you would need to know how to approach the cleaning, because there is no tool that would do the cleaning for all kinds of situations, but you can do a lot with FME. So next step, we would like to merge the data from the text numbers with the polygons. And in this case, the spatial relationship was quite simple. If we take another look at the data, we can see that every parcel number is inside the polygon, and every block number is inside the block. For this relationship, we have point on area over layer. However, the first step we would have to do would be to create a user attribute that would carry the block ID or parcel ID. And how would we do that? Dale has mentioned that there are tons of format attributes read with every data, and those format attributes can also be used by the writer if you write when you write in some kind of format. You can see all those format attributes as a long list, but in this case we would need to extract a text string from the text features.
Yes.
And the attribute is called, in this case, the data is coming from DGN, so the attribute is called IGDS text string, and we will rename this attribute into block ID for blocks and into parcel ID for parcels. After that, we can merge the text with the polygons, and the user attribute we just created would be transferred onto polygons. Then we write the data. In this case, I also somehow we were thinking alike, and I also picked a geodatabase as a destination format. We can take a look at the result, and this is what we've got. So these are parcels and blocks in our file geodatabase with information about block ID and parcel ID attached.
You know, we should mention, I don't know if this data is like this, but these nice cul-de-sacs, if those were arcs, that would come through as arcs. if you're going to file geodatabase. I don't know if this data was like that, but
I think that, yeah, I don't know whether.
But anyway, it
Not
does
sure, yeah.
work, and the snapper works with ARCs, and the MRF cleaner works with ARCs. So FME's geometry model is sort of CAD friendly. But having said that, I also think that most of the world's data has made one trip through a shapefile at least sometime in its life, and shapefile don't do ARCs, and so that means that it probably gets stroked out in that case. But
yeah, quite often we get polylines instead of ARCs.
yes, but file geodatabase would do ARCs with no problem.
We have mentioned that visual attributes like line styles and fonts and symbols are not that important for GIS, and actually are not supported by some of the GIS formats. And file geodatabase is one of those formats. However, there are formats that do support visual attributes. Let's try to write into MapInfo instead of file geodatabase. We will add another writer, and it will be one of the MapInfo writers. And the output will go into this folder. I will not create any destination feature types right now. What I will do instead, I will change the writer. So far we were writing into Cold Lake geodatabase. Now we will write into MapInfo tab. And this will be MapInfo tab as well. The data structure stays pretty much the same, although you mentioned that allowed geometries disappeared. It's because MapInfo can support multiple geometry types in the same table, while geodatabase requires only one geometry type per feature class. As we are writing into MapInfo, we probably do care about styles now. You can set the styles of the object using MapInfo format attributes, but there is an easier way to do that. We have another transformer that is called MapInfo styler. Let's add it on the way to the writer, and let's check its parameters. In this case, we are writing polygons only, so we would like to set the style for the regions. First of all, nice feature, you can select one of the MapInfo patterns. You don't need to know the number. You have the interface that is similar to MapInfo interface, and you can select from the list. Let's say this one. You can set the color. You can set, in this case, background color. I think we will get something orangey. Another one on the way to writing blocks, and let's do the same. Let's take another style. I think this one, and let's do the blocks nice and green. Let's run this translation. Nice FME 2015 feature. You see the number of features going through these links. So it's done. It's
wow, that fast.
Very fast. Yeah, but it was really fun to watch how features are going from the reader to the writer.
Yes.
And let's take a look at our data in MapInfo.
We're kind of having a gratuitous set of demos of different GIS software today, too.
Yeah.
Oh, looks nice and red.
So these are parcels. These are our green blocks. Yeah, blocks are green, and these are parcels. You can see.
Yes.
Or you can see, let's say,
okay.
the data in a browser. Yeah.
Yeah.
So this is it with this demo. Let's move to the next piece of data that we would like to convert from CAD into GIS. This one is more complex. This, as you can see, this is I would say, typical topo map, and it was created using MicroStation maybe even not. Maybe it even came from somewhere else, because I see actually some problems that probably were created while importing the data.
Okay.
So what do we have here? We have elevation points, like this one. And while the point sounds like it's supposed to be a point, this point is actually a circle with its all the data. As you can see, it's a 2D file. So there is no elevation on this circle. Instead, elevation is written as a text next to the point. And we can't even expect it to be on the same side. As you can see, sometimes it's to the left, sometimes it's to the right. Anyway, it's somewhere close to the circle. Elevation lines, they are also 2D, and they even have gaps in them with elevation written in the gap. And again, this elevation text is not linked anyhow to the line. On top of that, there is a bunch of cells. Some of them we probably want to use somehow. Some of them we might not care about, but they are cells, and we need to convert them somehow into GIS. Some cells we really probably care about. It's single trees. It's probably some kind of object. Another piece of data hidden somewhere here. These are, I'm trying to find the right spot. These are different fences. Like this is one of the fences, and the type of the fence is coded as line style, as a custom line style. So we would need to extract this information somehow. Let's take a look at the workspace that will process this. So first of all, let's deal with the elevation points. Elevation points, all of them are stored on the level that is named elevation points. So we read this level. There is something else, some other features on this level that we don't care about. So first of all, we will filter ellipses and text only to process them. Next step that we would do, we would need to attach the elevation information to the circle somehow. And in this case, the spatial relation is more complex, but it can be done with neighbor finder. After the neighboring circles and text are found, we would need to create again the user attribute, and again it's stored in IGDS text string that comes from the text features. After that, we would like to convert the circles into appropriate geometry type, and in this case we talked about points, so we would replace this ellipses or circles with points. And also what we would like to do, we would definitely want elevation points to be 3D. So with using 3D forces transformer, we would add the third coordinate to them. And after that, we are writing again into file geodatabase. It can be another format. Just happened that we happen to decide to go with the geodatabase time after time.
Yes.
So we are done with this part. Next one will be even more complicated part with elevation lines. So again, elevation lines are stored on a separate level, and it's called elevation lines, which is nice. And we only need from this level lines and text. The rest, for now, we would discard. Again, we are creating elevation attribute based on FME text string or IGDS text string, is the same thing. Then, what we would do, we would need to get rid of the gaps. Let's take another look at the elevation lines. Let's find a good gap and zoom close to it.
There's gaps in them.
Yeah.
Oh, right there.
This is a piece of elevation line, this is another piece of the same elevation line, and this is the gap between them.
Mind the gap.
Yeah, mind the gap. So let's fix this. What we would do, as you can see, there is a text sitting kind of in the middle of the gap. So let's convert this text into a point. Then we would find the rotation of the text. We would create a small short line that would be a patch for the elevation line. This is done with these several transformers. We are calculating the coordinates of the text, then we find the rotation of the text and add another coordinate in a certain direction and extend the point into line. After that, we would like to use the snapper again. We have our elevation lines and those short lines that are like patches, and we would like to snap them together. And after that, we can join the elevation lines to have one elevation line instead of pieces.
That removes the pseudo-nodes. There's an old term that was used here. I wonder who out there ever heard pseudo-nodes, but basically it means that lines are broken for no reason. There's no reason for them to be broken.
Yeah, absolutely no reason to be broken from GIS point of view.
Right, so let's join them together. That's happier for everybody.
Yeah, and also what happens when we join the lines, we transfer the elevation from those tiny short patches onto whole lines.
Yes.
And after that, the whole lines can be written again into our destination format, in this case, elevation lines.
And you have elevation now.
Yeah, unfortunately, the data is incomplete. We can try to fix it even more.
Yes. Yeah.
But there are not all the lines, not all the parts of the lines have elevation on them.
Yes.
And it's a quite complex.
Yeah, but we can get 80% of the stuff automatically, and then somebody has to go and clean it up. And that's a lot of times when you're doing CAD to GIS, you automate a big chunk of it, and a human has to go mop it up at the end, just depending on how good or bad the data was to begin with.
Yeah. And the last thing, we should try to do some kind of feature classification. We have another level in this DGN file, and it's called topo.
Yeah.
And there is actually all the rest of the map is all together on this level. We have some cells on that level, we have some lines with line styles on the same level, and it's totally not appropriate for a GIS format, especially for file J database. So first of all, let's try to separate all the cells, and we can separate them and code them based on the cell name. We have a very useful attribute read from the source data, and it's called IGDS cell name.
Yeah.
And we know that we can actually import those values from the source file, which is also very convenient. You don't need to type all of them.
Right. So we're going to get point features, and then we know that what kind of cell they were, and then you can save that if you want to.
Yeah. And in this case, we would like to create on our output. We would like to have a user attribute called symbol type with the name of the cell in it.
Because then someone can set up rules inside of ArcGIS to make them display nicely.
And we will see that.
Okay.
And the last one, let's try to write all the fences separately. And with fences, we have different custom line style, and we have a nice attribute called IGDS style name. Again, we will split all those lines by.
It looks Greek, but it's not, is it?
No, it's Russian.
Okay, I'm surprised.
This proves that we do support different encodings.
I know.
Yeah. So this is even more complex. We were talking about some additional rules that might be implemented in the destination format, and in this case, the fence type is actually a coded domain.
Wow. Okay.
And while we transfer just the integer numbers and write integer numbers in the destination file J database, we will see those fence types as nice words.
So you're translating file formats and language.
Yeah.
and code numbers. There's like
Yes.
3 translations going on at once.
Yeah.
Okay.
We won't run this translation, but we will open this data in
So it's like a
ArcMap.
cooking show. And we're back. And we have our...
And this is what we were talking about. As a file database doesn't support styles,
Yeah.
we didn't write any visual styles, any attributes that would transfer the styles. However, we had some values written into user attributes, and based on those values, we display the features differently. These are the bushes, these are some kind of grasses, there are some trees, as you can find. Those were the cells that we classified. These are our elevations, and if we check on information about the elevation, we will see that the elevation value is written into the attribute. Also, there are all different types of fences, and they, in this case, we didn't find good enough line styles. They just displayed with different colors.
Yes.
So I think we achieved what we had to.
Yes. It's always nice to see a nice looking map. So is that the end of your demos?
Yes, and we should probably switch to queries.
Right, so we'll ask some questions, or answers, not ask, we'll answer some questions here for just a couple of minutes, and then we'll hand it over to Mark. So I was watching the questions while Lena was talking there, and so Stephanie, if you want to switch the presenter over to Mark, that would be a good thing to do. But what someone was asking about different dialects of design files, like MGE. Did you ever work with MGE in your life?
I know what it is, and I was happy not to.
Okay, but yes, FME out of the box can read MGE with no problems. MGDM, I have a feeling I know who that is because I haven't heard of MGDM for about 10 years, and now within 3 days I've had several queries. But yes, MGDM was an extension of MGE, which not only created linkages from the design file elements to a database, but also maintained history. So all the deleted elements are still in there in the file. They don't get displayed, but you can see them. And yes, FME can read the deleted elements out as well. And then, of course, frame, or frame, as we say in Canada. Yes, frame data can be read. When you're reading a frame file, we fish out the UFID and some of those things so you can join to a database. I know Mark Stokes has, he loves doing frame imports, and we've been involved in many frame to small world, frame to G technology, these kinds of things. Someone else asked about projections, and yes, if you don't have a projection, it can be a problem. You have to talk to somebody. If you can identify tie points, FME has a warper in there that we could warp things for you. We can do affine transformations, but there's no substitute for elbow grease. Using the background map and the data inspector, you can tell if you're in the ballpark, but in the end, there's no magic wand. You have to figure that out. And if you have a custom coordinate system, yes, FME has about 7,000 or 8,000 coordinate systems in it, but you can also define your own. And so those are the questions that I picked out. Do you have anything else that you noticed, Mark, before we hand it over to you to go the other direction?
No, but I mean, I would mention there's the offsetter and scalar transformers as well. So
Yes.
you can, if you know there's a certain offset or a certain scaling factor that's being applied to your data, then in a local coordinate system, then you can apply them in FME as you translate the data.
Right, there's often unit troubles. For example, the CAD file's in millimeters, and you need meters. We didn't even talk about the joy of subunits.
Yeah, but you can work with them. So.
You can, if you really love subunits. If you know what that means, you're in an elite group in this webinar. But yes, and half the files have meters as subunits in British Columbia, and half of them have millimeters. So you have to kind of be on your toes.
It's
when you're dealing
okay.
with
It's
that.
worse when it's feet and meters.
Ah, come on.
That's-
Our American friends, they love feet because then they can choose from survey feet or international feet. There's so
Yeah.
many feet to choose from as well. So anyway, all those things are possible. Mark, do you want to take it away and guide
Sure.
us now as we go back the other direction? So you got some GIS data. You want to make a beautiful CAD file because
That's
that's where
right.
Mark likes to live.
Can I just check with our organizer that everyone's seeing my screen right now? And that's
We are. You've got a nice big Q&A through magnifying glass.
okay. And now you should be seeing that slide. Okay,
Yeah, our
perfect.
problem.
Okay, so the thing we're looking at here is we've got some data, it's stored in our GIS system, it's shaped files, and how do we represent some of the information in that shaped file in a CAD data set? And so I'll just fire up ArcMap, or open up ArcMap. I've already got it open here. And we have the exact scenario that Dale was talking about earlier. We have these features in the city of Vancouver, which are parks, and the little red dots indicate that it's a dog off-leash park. So we have a combination of area features, polygon features, whatever you want to call them, and point features as well. And if I zoom into one of these point features and query it, hopefully you can see that there's a couple of attributes on there. There's the park name and there's the number of hours that the park is open. So we've got different geometries, attributes to deal with as well, and the fact it's a point feature, well, we should really represent that as a cell when we write that data out into our MicroStation
A barking
output.
dog.
Yes, and we do have a dog cell. I don't think it barks at you, but
Doggone, you do.
okay, so I'm going to open up Workbench. So we're in FME Workbench again, and I'm going to create this workspace from scratch to translate this data. So we're going to translate the data with this Generate Workspace option, and our source data is shape format, so I'm just going to type in shape and select the data sets I'm working with, which are, let's see, in my Dropbox, demo 4, here we go. So we've got a few different things. I'm going to work with the off-leash parks and the park polygons. So I'm selecting those two shape files to read. Obviously the output format is going to be a MicroStation, so I set that. I'm going to write to version 8. The data set we'll write it out to, let's see, we'll write it to that folder. It's already got a parks.dgn, so I'm going to call it parks2.dgn. If I click in the parameters button here, you can see that we've got all these different parameters that we can set when we're writing a MicroStation file. For example, we can set the seed file. This is going to be two-dimensional data, so I'm going to change the seed file from a 3D one to a 2D one. And FME comes with a whole bunch of seed files predefined for 2D, 3D, feet, meters, version 7, version 8. So I'm picking 2D in meters, version 8. I've got a cell library I'm going to use. Again, FME comes with a couple of cell libraries. I'm going to use the one that's in my Dropbox, and it's Park Cell Library. And I can also set the output units to be master or subunits, and I've got different options there for handling different components in my output MicroStation. So I'm going to click OK, and FME is going to scan the source data, tell me what the source layers are, and set me up this translation, which is basically going to be the two layers on the left, my shape files, and the two items on the right are my levels in MicroStation. So, and we can see if I click the expand button, we've got some attributes in there. So how am I going to get the attributes into MicroStation? Because MicroStation doesn't really have attributes that are attached to features. It has what we call tags. And so if we look, I'm just going to zoom in a bit so you can see that, because I'm probably, there we go. So if we look in this navigator window in the left, I'll expand that. There's some more settings that control how the MicroStation data is created. Again, we can set the subunits, the type 3 elements if we're going to write those or not. We let FME compute its own seed file if we want. The key one I'm looking at here is write tags, yes or no. So I'm going to say yes to that. And when I say yes to that, any incoming attributes like the park and the hours, it's open, are going to be written as tags in the output. So that's solved the attribute problem. Okay, so what I can do now is start adding a few transformers in to transform the data, to write it to the output. And one of the transformers we have is called a DGN styler. And a DGN styler is the way that we can set different symbology for the features that we're writing out to MicroStation. So if I open this up and have a look, let's see, we've got color. Let me just expand that a little bit. Well, we have color and line style. I'm not going to write cells for the polygons itself, so I'm just going to ignore that. So we can set color as being bi-level if we wanted to. It's only for version 8, but I'm not going to do that for now. But that is a possibility to do that. We can set the color type. I'm going to go with the color index, in other words, use MicroStation colors. And let's see, color 0 for the outlines, which is black, and fill colors 2 is green, I think, isn't it? So there we go. So I'm just saying for these polygon features, set it to an outline that's black or white on a black background and with a green fill. I'm going to put another DGN styler here, and what this is going to do is let me set cells for the dog symbols. So let me just put a check mark against the cells, expand that dialog. Okay, so it's saying, well, which cell library are you going to use? Again, I'm going to browse to the one I had earlier. The cell name, I can click OK on that, open it up, and what FME will do is it will scan through that cell file, find a list of all the cells in there, and let me select which cell I want to write. And in this case, it's going to be one called Doggy Park. I get to choose which the cell mode is, so it can be shared or it can be the library itself, so each instance is itself separate rather than shared. We can write graphic cells, relative graphic cells, all the different sorts of cell types, and it gets very confusing, all the different cells that you can have in MicroStation, but FME does support writing all of those. And we can create the cell size by a scale factor of the original cell, or we can set master units, which is what I'm going to do here. So we can say the master unit is going to be 50. Now I'm typing them in manually there, but if there was an attribute I wanted to set it by, so I could say set that by attribute value, the number of hours that the park is open. So in that case, the cell would be larger the more hours the park was open. The fewer the hours it was open, the smaller the cell would be. I'm not going to do that now. I'm just going to set it to a fixed value. But that's one way we can increase and decrease the size in the MicroStation output. I did see a question about how you would change the output level. What I would do is on the right-hand side, just click on this button and say, well, I want to change the name from dog off-leash areas to dog parks, and that's all I need to do. If I change that, now my level has been changed, the name has been changed, and I should probably rename this as well, because park polygons isn't really a great level name. So we can do that, and I can rename them like that. And yeah, so let's see. Well, we'll run this translation, and you can see in the log window it's running, and yep, there we go. It took 1 second to translate 250 odd features there. Okay, so let's open that up and see what we got. So here's MicroStation, there's parks2.dgn. We'll open it up, and we'll need to maximize that window and fit everything into that window. And also, I guess we'll need to turn on the fill to make sure we see it in green. So there we go. I turn on the fill, there it is. So now I can zoom into this. Now where would my cells be? Maybe they ended up underneath. That would be unfortunate. Let's see. Anyway, we can see the levels there, the parks. I'm going to turn off the fill again just so I can see. There we go, there's the cell with a little doggy symbol there. So we've got the cell that's made up there, and that was a, let's see, we'll query that. So that was a graphic cell. If I use the tags dialog, there's the tags. I click the review tool, query the tags, and we'll see that the attributes that were on that data, the park name and the number of hours, that's come through as a series of tags on that data there. So that's
So Mark, I guess if you wanted to control display order, you could hold all the cells to the end and then have them written out at the end, because in CAD files, the order that stuff is written does matter, I guess.
That's right, yes. And so
also for DGN we have a priority attribute.
Okay.
yes, and I was just going to say there's a whole bunch of different attributes you can see on the feature type here, which give you a bit more control over things that you don't have all exposed in the DGN styler. So we can look through some of these format attributes, and they'll be in there. So you said there was a priority one there, Lena? I don't see that, but I could just be... oh, there we go, IGDS element priority. So we could expose that, and we can right-click and say, edit the value of that and set it to a value of 1, and set the other one to a value of 2 or 0 or whatever would get that in the right order. The other thing we could do is, for example, I could put a label on there as well. So I could say, well, we've got these there, let's create a label. I'm going to create a new level to put those on, and we'll call it labels. And I'm just changing that and creating a label out of it. And again, I could get that from an attribute. In fact, why don't I do that? We'll put the park name as a label, and the label can be, say, 50 units high. And we'll probably, I'm going to use the offsetter transformer just to offset it by 50 units. Well, I say 20 units in each direction. Now we'll say 50. What the heck? And see what that looks like. So now I just got to go back to MicroStation and close that file, because FME won't like it if I try to overwrite a file that's open. And okay, let's go back into that. Let's have a look if we've got some labels, which we should do. So there we go. So now we've got a label in there as well with the name of the park. So each park will have its own label now. So that was just a very quick example of translating from shape into MicroStation. And there's a whole bunch more we could do, but I don't want to go into too much detail right now. So that was that problem. The next problem I wanted to look at very quickly, because we're running out of time, was three-dimensional data. And in this case, what I've got is I've got a bunch of building footprints, and I have some LiDAR data, and basically I want to process that data I'm going to use the LiDAR to give height to my buildings, and then extrude them to that and write it out to well, whatever format I like. And I've already got a workspace made up that did that. So I'm going to click the run button, because this will take about a minute or so to run. So what's happening here? Well, I'm reading some point cloud data. I'm splitting it up based on the classification value. So in this case, classification 1 is vegetation, 6 is a building. So I'm splitting it up by classification and keeping all the building points. Thinning it out a bit, because we don't really need as many points as we have, and it'll just make this workspace run a bit quicker. This is where the building footprints are being read. These are MicroStation footprints, polygon features. So the key point here is the point and area overlayer. We're overlaying the point cloud onto the building footprints, and that gives the footprint an elevation, and we basically pick the highest elevation out of those. So we say whichever point is the highest in the point cloud, that's going to be the height of that building. And then we're going to use the extruder transformer, which just says, okay, turn that flat two-dimensional polygon into a three-dimensional solid, and then we're going to write that out to MicroStation as well. And we're also going to send it to the FME data inspector, so we can have a look at the data in there and make sure everything's okay. So that should just take another few seconds to complete. We're 90% of the way there. So there we go. We're just finishing it. So there's a translation. Let's have a look in the data inspector. The data's just coming up now. So this should be our 3D buildings created from two-dimensional building footprints with some LiDAR data thrown in there to extrude that. So that's in FME, in the data inspector.
So you go to 3D PDF or to ArcGIS or wherever.
That's right. I was going to open in MicroStation, but also we can look at it in 3D PDF, like you say. So I did that earlier. I ran that earlier and opened it. I could open that up in 3D PDF and show you that. So let's have a look at that. So this is what it looks like in 3D PDF, which a format I really love and not many people know about. Like, who would know that you could open this up in a PDF file? Not many people, I don't think. Also, I wrote it out to a geodatabase, so let's have a look at it in ArcScene. Let's see. Demo 5, geodatabase, buildings, and there we are in ArcScene. So we've got the data written out to that. So we started out in MicroStation, we wrote it out to PDF, geodatabase, also MicroStation as well, so I could open that up in MicroStation if I wanted to and show that in 3D. The other thing I was messing about while they were doing, Lena was doing her demos earlier, was adding some appearances to that.
Yeah.
I couldn't find a really good appearance to add, so I just threw a photo of myself in there, put it on the appearance. So appearance setter just adds a texture to three-dimensional data. I ran that translation earlier, and I got this rather horrific-looking outline of Vancouver.
It's Markville.
It is. I got to say that BC Place would look so much better with my face across the top of it. It just looks awesome. So okay, that wasn't a very good texture, but you get the idea. I hope that you can apply textures to features, and that workspace took me about 15 to 20 minutes to create. It wasn't long. So once you're familiar with FME, and I'm no longer the presenter, so I guess I was running over time. So I'll hand it back to you guys.
So who is the presenter? Is it me, Stephanie? Let's see. I don't know why Mark got kicked off. Well, we're going to wrap it up here anyway, and with luck, Stephanie's going to make me the presenter in a moment here. Let's see what I have to do. Yes, whoops. I have to do that. And I'm going to do this. Okay, so that should be good. Yes. So we're out of time, so I'll just mention that, of course, we can reproject. We can connect to databases. I did a join. We can use the SQL executor. Yes. And, of course, all this stuff you saw today can be automated in batch modes, in server modes. We have all kinds of automation tools. A key part of our technology offering is that you set this up and then run it over and over again on directory fulls of files. We've got a couple other webinars coming up. If you like what you saw today, we're going to be doing a similar kind of thing with raster. This is going to be a different webinar than our usual raster because we're going to dig into specific customer success stories that we think integrate a bunch of interesting raster options. And then on October 15th, we're talking to some friends in the utilities as well about how they've been using FME there. So that's going to be focused more on utility kind of workflows. And we always have free training for you to try. If you go to safe.com/training, you can sign up there. We have various online options where there's an instructor. We give you a Amazon machine for you to play with all the software, and you can do both desktop as well as server. We got an advanced one coming up. Mark, that's exciting. What's some of the stuff in the advanced one?
Oh, you've just put me on the spot. Performance is the one of the big ones. How do you get the maximum performance out of your data translations?
Yes.
That's a really important chapter on that, I think. And then there's the event schema mapping as well and things like that. So attribute handling and everything.
For those that don't know, Mark is our training architect and is the man behind the materials that are presented here. Are you presenting the advanced one yourself, Mark?
I suspect I probably will be, yes, or at least part of it.
So that sweet molasses voice will be there 2 days in a row and during those dreary days of October for you to tune into. So anyway, with that, we'll just basically I'll say goodbye to people. We'll hang around and do questions and answers, but I do know that we're at the witching hour of 9. So thanks so much for joining us. We're going to hang around and answer some questions, throw in the cameras, and kind of go through some things if you have to leave. Thanks so much for spending time with us. And don't be afraid to be in touch with us at info@safe.com. There will be a follow-up email with links to all this stuff. that you can look at afterwards. And we basically love, our passion is solving people's data translation problems, and we just love the gnarlier the better. And we'll sit around here and tell some war stories in a few minutes, but that's what gets us up in the morning, that's what gets us here at SAFE, so don't be afraid to ask us. And there really are no gnarlier translation problems than those that involve DGN files. And so all of you that attended this are part of a very elite group that know and love that. So I think we'll say goodbye, and then we'll look at some questions and answers. So let's see what we got. I'm going to share my webcam. Thank you, Stephanie, for doing that. So, Mark, any other things that you wanted to add on?
I don't think so. No, I think I'd pretty much covered what I wanted to do. So. Yeah.
There was someone that asked me, actually we have someone from Esri online. So thanks very much for that. And they said that if some people want some general tips about dealing with things that don't have a coordinate system, I'm just going to send out a link to an Esri knowledge base article there. That of course it's ArcGIS centric, but the principles are sound that some of you may want to look at. This is actually the article there. So in terms of other questions,
someone was asking about reference files and if we could read reference files, which we can.
Yes, that must be. Yes. If we go to actually, let's just look. If we add a MicroStation reader.
Yeah, there's definitely.
Are people seeing me? Yeah. Somewhere in here, there's a thing about following. Yeah, read reference files. Here we go.
So you can read the first one or keep crawling through them and add infinitum and as far as you want. Yes.
And isn't it fun when you have to override the global origin? Don't we all love that? That's when you got. I think for a while about half the forestry files in BC had an incorrect origin, and the other half were correct. So that made it fun.
So if you are not completely confused, you can get into it.
Yes. And someone also asked about frame. Here's from you click this button, and then we will show you the UFID and I forget what the other one was. The secondary, I don't remember. It fishes out some other attributes. And this is if you want to get to MS Link Fun, you can both read and write MS Links, and that does that. And world files, if you happen to have one. I know that there was I think maybe the Esri folks have a utility that'll make world files.
Yeah.
So again, the Esri people have some nice tools for that, and we'll apply them if they're there. So those are just a handful of those kinds of options. Anything else? Any of Mark Stokes or anybody like that? Any other questions worth? I know some people asked, what about if we're going to a GIS format and we want to style it? To Esri World, we don't have anything for you. But for MapInfo, for KML, for PDF, there's stylers for all those things.
And if there is no styler for more rare format, you can style using format attributes.
Yes. Yes.
And there is an the demo I showed with the dog parks. We do have the AutoCAD equivalent of that using blocks and a DWG styler transformer. So that's certainly possible as well.
I also have some folks mentioning that MicroStation V8 can have a coordinate system right in there, and that is a good trick to be aware of. You can certainly have it in the seed file. Regan would have to chime in. I don't think that SAFE knows the keys to the car to be able to read and write that automatically, but Dave, if you're able to share that with us, that would be great.
We are working on this. We have a PR file, and we hope to implement it.
Yes, we do know that MicroStation uses the same library as we do for coordinate conversion, so if we ever can figure it out, it should work really well. So can FME add a tag to a DGN file with a UUID? Yes, we can. There's a UUID generator.
Yeah, I don't see why not.
Some people asked, can we go CAD to CAD? If you read from MicroStation, certainly you can write to MicroStation and fix it up. If you had bad origin files, or if you wanted to move levels around or split things or add cells, rotate those dog symbols of marks, all that stuff can be done, right, Mark?
Absolutely, yes. We have the geometry, my brain's gone, the geometry repairing tool.
Oh, the validator?
Geometry validator, that's the word, yes. That's a great transformer
with its own logo.
Yes, that's an excellent transformer.
if we throw it down, if you know your transformers, I didn't actually show that you can search them over here, but you can also type in here. If I type GV, I think that's what it's known as to its friends, and then you can pop this open, and here we get into all, and many of these are wonderful CAD geometries that are duplicate points. They are, I dare say, a bit corrupt sometimes, and so on. So anyway,
they look good, but are not that perfect, as a matter of fact.
Yeah, the beauty is only skin deep sometimes. Yeah. So let's see, what else would we say? Somebody asked, somebody from Denmark was tuned in and thanked us for showing so much Lego today. So thanks, Danish friends, for having that.
On that subject, I being an ex-surveyor, I sort of created a building survey of my house when I moved in, and used FME to convert it from MicroStation to a 3D format, and then send it off and get it printed out. So you can even use FME to do things like that.
Yes, wonderful.
So there's 3D formats we support other than the ones I showed, like specific 3D modeling formats.
I was going to tease you about Minecraft, Mark, and I don't think I did say that, right? We could have output.
We could have output to Minecraft, yeah.
We could have put Vancouver into Minecraft, and then somehow had Mark's face on everything there.
Mm-hmm. Well, I think I get a lot of sympathy from folk here, because we're talking CAD people, like we're talking splines, and we're not talking big lumps of blocks.
Yes.
So that's anyway. That's my beef with Minecraft.
In the LiDAR case, to get the maximum, there is also a point cloud statistics calculator that gives you means and standard deviations and stuff. So if you're afraid a bird was flying over the building at the time, you may not want to take the maximum, but you might want to take the 95th percentile or something like that of the height. So that's possible with the point cloud statistics calculator, and it runs like stink as well. That's the technical term.
I should have tried that, yes. What I did with mine is I clipped the point cloud to the building outline, and then dropped it to points, and just picked out the highest elevation.
So slightly faster would be do the clip, but then run it into a stats calculator.
Yeah.
And then group that by the building ID, and then you'd get an individual set of stats for each one, and then you can do a little bit better. Yeah, it'd be a fun one to try. Let's see. Some folks from Brazil want to know if we're going to send them Lego bricks afterwards, and sorry, we're not going to. Yes, DXF is totally fine. Somebody's asking. I think the AutoCAD people feel a little bit out of place today, but it was advertised as a MicroStation one. But we do love the AutoCAD people. Yes. Let's be very clear. And actually, FME. I wrote the DGN, and the other co-founder of SAFE, Don, wrote the AutoCAD about the same time 20 years ago. So we have a deep and rich history and tradition with AutoCAD, and we could probably do a 4-hour session on AutoCAD files.
Easily.
Yeah. So I think unless any of our panelists want to chime in, should we bid everybody adieu?
Sure.
Let's see.
I mean, I think we could get questions all day if we sat here, but
I would love. I just love talking MicroStation. I didn't get to tell my story about Z or Z high and low. I tell you the truth, people. 2D in MicroStation V7, you had a concept of a 2D file or a 3D file. The 2D file did not store Z or Z values on all the coordinates, and because we're in a PDP-11 environment or we're worried about space, people would often choose the 2D file. But somebody along the way figured and realized that in the 2D file, every element has a bounding cube attached to it. Whether you're in 2D or 3D, you have a X-min, X-max, Y-min, Y-max, and the Z-min, Z-max. And here's, 8 or 16 perfectly good bytes of space that aren't being used in the 2D file. And I do not lie to you, people put database linkage keys. Basically, they put an ID into the Z-low and the Z high, so they could join to a database without using any more space. And I always think that's one of the most crafty and clever things I ever saw done with a DGN file. Have you heard of that one before, Mark?
I haven't, no. That's very inventive.
I think that one takes the cake, or maybe it takes the muffin.
Or maybe the T-shirt on a muffin.
It takes the muffin. So I think that's our sign that we should end.
I see another couple of questions that we can answer quickly. PDF to shape. We don't have a PDF reader, so that's not possible,
You know,
unfortunately.
but Hein, please do send us a PDF that you are interested in. I was doing some research with one of the teams in the last couple of weeks, and I would say that there's hope there. Before there was no hope,
Oh,
but
really?
now there's a bit of hope. Please send that in. We'd like to give it a peek.
Yes, we do have a Minecraft writer.
It's
someone
actually in
was
SP4. There's
Oh,
one
it
where we
is?
need a Minecraft styler, though.
Okay.
I know that Lena's husband, and I can tell you, Lena, Dimitri works at SAFE as well, and he is not addicted to games. It's really part of his job right now.
Oh, really? Because it's hard to tell right now.
When he's home at night, late at night, busy working with Minecraft,
Oh, it's not playing, it's just for work.
he's only working.
Okay,
He's
good.
only working. We've actually been working with the National Park Service and some beautiful prototype ones. We'll probably do a webinar on that as well. But Dimitri's found that he has to sprinkle bone meal on the trees to get them to grow.
Yeah, I've heard about that. Yeah, it's good to know. I thought he's getting into gardening. Was very surprised. Apparently, it was Minecraft.
Yes, yes. So someone else is asking about the cost of FME. If you go to our pricing page, let's see, there is a safe.com/pricing. You can see it there. So just go there. You can see that, Lauren. That should do that for you. Rhinoceros would be fun to do. Rhino is a 3D file format. We don't do it now. Actually, we didn't talk much about Revit. That's also a big thing in IFC. That's sort of higher-end CAD. Eventually, Bentley Architecture. We didn't say anything about iModels. We're talking with Bentley about that. People asked about ProjectWise. That's Bentley's file management thing. We don't have a native support for today. We're building towards it. If you want, today you could use our fancy HTTP and authentication stuff to read and write into ProjectWise. We do want to make that easier. If that's of interest to you, let us know. So those are just some other quick things. So I think, as Mark says, we could keep going all day, but we got to eat our muffins, and we probably should call that quits. So I think that's it. Thanks everybody for tuning in.
Okay. Thanks, folks.
All right, Stephanie, we'll ask you to shut us down gracefully because I'm scared to.